the antiderivative, and I don't need you to memorize any new rules. This is going to be using the same rules to find the derivatives. You just have to work backwards. So just like when you're finding the derivative, you want to rewrite everything in terms of like a power so that you can use the power rule, but this time we'll just be using it backwards. So you want to label, so please make sure you label your functions. Do not just write equals, write it f of x equals, so that when you take the derivative or the antiderivative, you also use correct notation. So that's going to be 5x to the fourth minus 12x cubed plus x to the 1/2 plus 1/3 x to the negative 2. Notice that we're just pulling out the x, so the 1/3 stays where it is, plus 4 sine x plus 6. I also want to point out, a lot of students do this, and it kind of drives me nuts. They start taking the derivative or the antiderivative, and then, so they'll do like the antiderivative for half of it. So they'll do like x to the 5th, spoiler alert, minus 3x to the 4th. And then they'll get stuck. So then they'll rewrite like half of it. So they'll start doing half as an antiderivative, and then the other half they'll like just leave as the original function. So please don't do that. Please make sure you just rewrite the original function. Just take the time, rewrite it first. It takes 30 extra seconds, rewrite it, and then you can start looking at antiderivatives. So what would give me a 5 in the front and then add 1 to the power? Okay, so if I add 1 to the power, I get x to the 5th. So I know it's going to be something x to the 5th. And then because you'd be multiplying the 5 in front for the power rule, it's just going to be 1 x to the 5th. So what I recommend you do is, it's almost like guess and check, working backwards. And so the derivative of x to the 5th is 5x to the 4th. So I just kind of like, I deal with the power, and then I figure out, okay, well, does the coefficient match if I take the derivative? So likewise, I have negative 12x to the 3rd. So that's going to be something x to the 4th. Okay, well, if I multiply the 4 in front, what do I have to multiply 4 by to get negative 12? And that's going to be negative 3. And I just double check. Negative 3 times 4 is negative 12, and then it'd be x to the 3rd. All right, I have x to the 1/2. If I add 1 to that power, I get x to the 3/2. So again, we're doing power rule backwards. The power rule says subtract 1 from the power. Power rule backwards means we add 1 to the power. So I have x to the 3/2. Now, what would I multiply x to the 3/2 by to just get a 1 in front? And that would be 2/3. Because 3/2 times 2/3, numerators and denominators cancel, I just get 1. Okay. My next one, I have x to the negative 2. If I add 1 to that power, it would be x to the negative 1. Because again, if I were to subtract 1, when I go back and check the derivative, I should get negative 2. So I have x to the negative 1. Now, what would I multiply negative 1 by to get positive 1/3? And that would be negative 1/3. Because negative 1/3 times negative 1 is positive 1/3. And then if you subtract 1 from the power, you get negative 2. So guess and check. The antiderivative of sine. So this part can be kind of confusing. The derivative of sine is cosine. The derivative of cosine is negative sine. So what if you go backwards? Okay, well, if you go backwards, the antiderivative of negative sine is positive cosine. So then the antiderivative of positive sine is negative cosine. And the 4 just kind of sticks around. So again, just double check. If you take the derivative of negative 4 cosine, the derivative would be positive 4 sine, because the derivative of cosine is negative sine. We have to change the signs when you take the derivative of cosine. So the antiderivative of sine, you have to change the sign, etc., etc. And then the antiderivative of 6. So what derivatives gives us 6? And that's 6x. The derivative of 6x is 6. All right, and then lastly, we're going to end it with plus c, plus a constant. Now, why do we have to do that? What is the derivative of any constant? Like if I made this like plus 1, the derivative of 1 is 0. What's the derivative of plus pi? The derivative of pi is 0. The derivative of negative a million. Is that enough zeros? Yes. Negative a million. The derivative of that is 0. So we have an invisible 0. The antiderivative is any constant. Not any constant times an x, not any constant times x to the whatever power, not c to a power. It's just a constant. As long as it's a number, just a plain old number, whether that is a decimal or an integer or a fraction, doesn't matter. If you take the derivative of it, you get plus 0. So an antiderivative is always going to include a plus c at the end because the derivative of that plus c is 0. Okay? So this is my antiderivative. You don't have to do anything else fancy with it. I'm going to go ahead and just leave it. I just kind of ran through half the answers. Hold on. X to the 5th minus 3x to the 4th plus 2/3 x to the 1/3 minus 1/3 x to the -1 minus 4 cosine x plus 6x plus c.